Texan Global School. Distance from a line to a point. In this class, the perpendicular distance from a given line to a given point is analyzed as an application of the normal form. Starting from a straight line L and a point P, 1, with coordinates x1, y1 in the Cartesian plane, we can determine the perpendicular distance d between the line and the point. Let's draw a line L' parallel to L and a normal line N starting from the origin. As we can see, a positive theta angle is generated. In this way, we can obtain the distance d since we have directed line segments seen in previous classes. Then, the distance d is the directed segment AB, which can be obtained by subtracting the segments OB minus OA, which are also the distances P' and P of the normal form of a line. Since in the previous class, P was defined as the length of the segment from the origin. As the point P, 1 with coordinates x1, y1 is on the line L', then the normal form of the equation of the line is x1 times the cosine of theta plus y1 times the sine of theta minus P' equal to 0. So P' is equal to x1 times cosine of theta plus y1 times sine of theta. Substituting P' in 1 results that the distance d is equal to x1 times the cosine of theta plus y1 times the sine of theta minus p. Thus, we prove that the normal form of a line is used to obtain the perpendicular distance from a line to a given point. But as demonstrated in the previous class, this is the equation in the normal form of a line defined by the general form, which is transformed by dividing the general form by r as demonstrated previously. In this way, we proved that it can be used to obtain the distance of a line to a given point, which can be represented as shown on the board. In summary, we have the theorem that says that the distance d from the general form of the equation of a line ax plus by plus c equals 0 at a given point P, 1 of coordinates x1, y1. It is obtained by substituting the coordinates of the point and the coefficients a, b, and c in the formula to obtain the perpendicular distance from a line to a point, given as d equal to the absolute value of a, x1 plus b, y1 plus c, all divided by the square root of a squared plus b squared. Let's look at a first example. We will find the distance of the line x plus 3y minus 2 equals 0 to the point P, 1 of coordinates 1, 2. First, let us graph obtaining 2 points. So, propose values. If x is equal to 0, by substituting and solving in the original equation, results that y is equal to 2/3. We obtain the first point of coordinates 0, 2/3. And if y is equal to 0, results that x is equal to 2. Then the second point is 2, 0. Thus, we can see the tabulation with the 2 points to be able to graph the line x plus 3, y minus 2 equal to 0, and the point P, 1 with coordinates 1, 2. Remember that the distance is perpendicular from the line to the point. Now, from the general form of the equation of a straight line x plus b, y plus c equal to 0 results that a is equal to 1, b is equal to 3, and c is negative 2. And from the given point results that x, 1 equals 1, and y, 1 equals 2. Substituting those values into the formula to obtain the distance from a line to a point, we obtain a distance of 5 over the square root of 10, approximately 1.581. Let's look at another example. We will find the distance of the line 4x minus 5y plus 10 equal to 0 to point P, 1 of coordinates 2, negative 3. First, graph obtaining 2 points. Hence, propose values. If x is equal to 0, by substituting and solving in the original equation, we obtain that y equals 2. We then obtain the first point of coordinates 0, 2. And if y is equal to 0, results that x is equal to -5/2. So the second point is -5/2, 0. Thus, the tabulation is shown with the 2 points to be able to graph the line for x, -5y plus 10 equal to 0, and the point P, 1 with coordinates 2, -3. Remember that the distance is perpendicular from the line to the point. Now, from the general form of the equation of a straight line x plus b y plus c equal to 0, results that a is equal to 4, b is equal to -5, and c is 10. And from the given point results that x, 1 is equal to 2, and y, 1 is equal to -3. Substituting those values into the formula to obtain the distance from a line to a point results a distance of 33 over the square root of 41, approximately 5.15. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com